Hi Bethany, here's the video about how I would approach the logic behind proving a summation mathematical induction. So what we have is a whole series of terms, obviously adding up to this. So we're assuming that this is the sum of those n terms on the left-hand side. So the very first thing we have to do in our induction process is to show that this actually works for one case. And the case that we do is the simplest case, so we let n equal 1. And in that case, the left-hand side of our summation is just the first term. It's 1 on 1 times 2 times 3, which is 1/6. And the right-hand side is our expression for the summation, which is 1/4 minus 1 on 2 times 1 plus 1 and 1 plus 2, which is then 1/4 minus, and our fraction here is 2 times 2 times 3, which is 1/12. And 1/4 minus 1/12 is 3/12 minus 1/12, which is 2/12, which is 1/6. So we could have put all that in the calculator, but the main thing is that we've proved it for one possible case. Then our second task is just to say, well, okay, let's just assume that it's true for any value of n, and we're going to let that value of n just be k. So we have to write this thing down, and I'll be a bit briefer here. So going all the way up to the kth term, k plus 1 and k plus 2, and we're going to assume that that is equal to what our formula says, which is 1/4 minus 1 on 2 times k plus 1 and k plus 2. Now the next step is, I think, the crucial one. So here we're going to investigate what happens when n equals k plus 1. And what we are going to prove, if mathematical induction works, is that the sum of the first n terms, which is all of this stuff, plus, if we then put in the nth plus 1th term, so the very next term in the series, that will actually equal the sum of the first n plus 1 terms, which is entirely logical. So we're going to prove that, and now I just flesh that out, so it gives us a target. So the sum of the first n terms is all of this stuff, but I'm not going to just write all of that stuff. I'm going to write what we're assuming all of that stuff is equal to, which is this thing. So that is 1/4 minus 1 on 2 times k plus 1, k plus 2, plus the n plus 1th term, so that is this thing here with k plus 1 written in it. So that'll be 1 on k plus 1 and k plus 1 plus 1, which is that, and k plus 1 plus 2, which is that. And we're going to hopefully prove that that thing on the left-hand side, which is this, is equal to the sum, what the formula says would be the sum of n plus 1 terms. And the formula says that that would be 1 on 2 outside of k plus 1 plus 1, which is that, and k plus 1 plus 2, which is that. So that then gives us, this line here, gives us the process that we're going to work through. We're going to take what is on the left-hand side, and we're going to show that it equals the thing on the right-hand side, which was our target. So now we're just doing algebra. So we've got 1/4 minus 1 on this, plus this, and now we just remember our algebra rules. I'll just slide this up a little bit. The quarter, I'm just going to leave sitting there because that's the quarter just there. So really I'm focusing on the bit to come. But I'll try to keep writing the quarter so I don't lose it. And I'm going to add these two fractions together. And like every fraction sum, I'm going to do that by getting a common denominator. So something that all of this stuff will divide into. So that would be 2k plus 1, k plus 2, k plus 3. So what we can then see is that 2 times k plus 1, k plus 2 divides into our common denominator, k plus 3 times. So now I'm going to put a really big bracket around this so that I can just focus on the summation. So I've got k plus 3 times the 1, which is sitting here. So that's k plus 3 plus, well actually I have to be careful now because I've put brackets around this whole thing. So that plus just there will actually become a minus. So that is minus, so that this minus times this minus gives us that plus, which was there. And now k plus 1, k plus 2, k plus 3 all goes into the bottom 2 times. So I have that. So now I've got a quarter minus, and the top line of my denominator is k plus 3 minus 2, which is k plus 1. The bottom line is 2 times k plus 1, k plus 2, k plus 3. And the k plus 1 cancels out. That leaves me with 1/4 minus 1 over 2 outside of k plus 2 and k plus 3. And of course that's exactly what my target was. So that equals the right-hand side. And then we know that the last line is really important. So the last line is saying that we've shown that if it's true for any value of n, then it's true for the next value of n, so n equals k plus 1. And we also proved it was true for the first possible value of n, which was n equals 1. So by mathematical induction, it's true for all n. Hope this has been of some use.